Your air filter has a blind spot. That $300 machine humming in the corner, the one with the blinking green light that tells you everything is fine, it's doing exactly what it was designed to do, capturing dust, trapping pollen, removing particulates from your air. If wildfire smoke is rolling through, if pet dander makes your eyes water, that filter is genuinely helping you. But here's what it's not catching: the formaldehyde leaking from your pressed wood furniture, the benzene off-gassing from your new carpet, the volatile organic compounds bleeding out of every synthetic surface in your sealed modern home. These aren't particles, they're gases, and they pass through HEPA filters like the mesh isn't even there. Because at the molecular level, it isn't. HEPA filters were designed to catch solid matter, particles 0.3 microns or larger. They do that brilliantly, but VOCs are individual molecules. Different problem, different solution required. Modern buildings have created a new kind of air quality challenge. We've sealed our homes so tight for energy efficiency that air exchange has dropped dramatically. We've filled those sealed boxes with furniture made from pressed wood bound with formaldehyde-based resins, coated surfaces with synthetics that off-gas for years, and then bought a particle filter assuming we'd solved air quality. We solved half the problem. The other half, the chemical half, requires a different approach entirely. And medieval architects figured out the core principle 800 years ago. The problem with tightly sealed construction isn't just what's floating in the air, it's what's dissolved in it. That new furniture smell, that's formaldehyde. The EPA has measured formaldehyde levels in new homes at concentrations 3 to 10 times higher than outdoor air. In a well-ventilated home, this is manageable. In a sealed, climate-controlled box, concentrations build. The solution isn't better filtration, it's air replacement. Continuous, passive air exchange that dilutes and removes gaseous contaminants. And this is where medieval architecture has something to teach us. In 1164, Norman rulers in Sicily completed a palace called the Zisa. The building was designed as what modern architects call a bioclimatic machine, a structure that uses natural forces to regulate its own interior environment. Its primary achievement was massive, continuous air exchange powered by nothing but physics. Here's how it worked. Cool air entered through a large courtyard at ground level. A central fountain chilled that air further through evaporation, the same principle that makes you feel cold when you step out of a pool. As that cool air absorbed heat from the interior, it became lighter, less dense, and physics took over. Warm air rises. The heated air climbed naturally through the building, drawn upward by 2 ventilation towers built into the palace walls. These towers, heated by the sun on their exterior surfaces, created what engineers call thermal buoyancy. The warm tower walls heated the air inside them, accelerating its upward movement. This created negative pressure at the bottom of the building, actively pulling fresh air through the courtyard. The system ran continuously, powered by nothing but the temperature differential between inside and outside. The Sicilians even hung wet sheets beneath ceilings, which provided more evaporative cooling and trapped some airborne particles. But the primary mechanism was air volume, the sheer quantity of fresh air cycling through the space every hour. This wasn't molecular purification, it was dilution through replacement. The same principle as opening a window, but engineered into the architecture itself. This principle, the stack effect, has been used across cultures for thousands of years. Wind towers in Persian architecture, Roman hypocasts circulating heated air beneath floors. Even the humble chimney, developed around the 12th century, revolutionized indoor air quality. It didn't just remove smoke, it created negative pressure that pulled fresh air into the building, continuously replacing the interior atmosphere. The physics are simple. Warm air is less dense than cool air. It rises. If you provide an exit point high in a structure and an entry point low, you create a continuous convective loop. No electricity required, no moving parts. Now here's where medieval practice adds another layer. People in the plague years didn't just move air, they believed they could treat it. They burned specific aromatic materials in their homes: rosemary, juniper, frankincense. They believed these scents could drive away the miasma, the bad air they thought carried disease. They were wrong about the mechanism. Disease isn't spread by smell, but modern research suggests they may have stumbled on to some genuine benefits. We now know that many aromatic herbs contain compounds with documented antimicrobial properties. Rosemary oil contains compounds that can disrupt bacterial cell membranes in laboratory conditions. Lavender contains linalool, which shows inhibitory activity against various bacteria in controlled studies. I want to be careful here. Laboratory antimicrobial activity doesn't automatically translate to effective room-scale air purification. The concentrations in a petri dish aren't what you'd achieve burning herbs in a living space. But the friars at Santa Maria Novella in Florence kept meticulous records during the 1348 plague. They documented their constant use of frankincense, juniper, and rosemary. They recommended going to fresh air, carrying aromatics, and scenting the home. The burning braziers they used would have created convective airflow, a thermal updraft pulling fresh air in at lower levels. The air exchange component was sound. So here's the practical synthesis for modern application. And let's be realistic. You're not going to replicate 800 years of architectural refinement by hanging some wet cloths in your stairwell, but you can apply the core principles. The foundation is the stack effect. Remember, warm air rises. If you create an exit point high in your home, a second-floor window, an attic vent, an operable skylight, and an entry point low, you create passive airflow. The greater the height differential between the two, the stronger the effect. Opening a ground floor window and a second floor window at the same time creates cross-ventilation, enhanced by this thermal effect. The aromatic component is supplementary, not primary. Heating dried herbs like rosemary or lavender releases their volatile compounds. A simple method is a clay pot over a candle flame filled with dried herbs and water, which will continuously release compounds through steam. Position this near an area of air intake. At minimum, it improves the subjective quality of your air. It may do more. This approach, continuous passive air exchange, dilutes the gaseous contaminants that no HEPA filter can fully address. VOC concentrations drop because you're replacing contaminated interior air with fresh exterior air. It's airing our room, but engineered to happen continuously. What this approach cannot do is match the efficiency of a good HEPA system for particulate removal. If your primary concern is dust, pollen, or wildfire smoke, a quality air purifier remains your best option. These are different tools for different problems. The limitation of modern air quality thinking is that we've focused almost exclusively on filtration while neglecting exchange. We've sealed our buildings tight, filled them with off-gassing materials, and then tried to clean the trapped air rather than replacing it. The medieval approach prioritized air movement over air treatment. Today, the ideal approach combines both strategies: HEPA filtration for particulates and genuine air exchange, not just recirculation, to dilute the gaseous contaminants that no filter can fully address. Your HEPA filter isn't a gimmick for what it's designed to do, but if you think it's addressing formaldehyde and the full spectrum of VOCs in your sealed modern home, you're missing half the picture. The medieval builders of the Zisa understood something we've partially forgotten. Buildings need to breathe, air needs to move, and sometimes the oldest solutions address problems our newest technology still can't touch. Open the windows when outdoor air quality permits, create convective paths through your living space, and stop assuming that recirculating filtered air is the same as replacing contaminated air with fresh. The stack effect is 800 years of proven physics. Use it alongside your modern tools, not instead of them. That's not choosing between past and present. That's combining the best of both.